Right, you are joining with the missile paper number 2 discussion. There are 10 MCQs. Each 2 days you get set of 10 MCQs. So this is the discussion of the second set of 10 MCQs. So the first question, select the correct statement. Polarizability of F minus, Cl minus and S2 minus ions increases in the order of F minus, S2 minus and Cl minus. This is completely wrong because polarizability, it mainly depends on the charge and the radius, right? So when you consider charge only, then you consider the radius. So actually S2 minus should be the largest. S2 minus and then Cl minus and F minus, it should go with the radius. So these two are compared with the radius. So Cl minus has a larger radius than F minus and S2 minus has the largest radius than all these two. So polarizing power of lithium plus sodium plus magnesium 2 plus decreases in the order of. So polarizing power is also the same. When the charge is very large, polarizing power is large. When the radius is small, however, polarizing power is large. So actually lithium plus should be larger than sodium plus. So this statement is also wrong. Electronegativity of oxygen, fluorine, chlorine, sulfur decreases as. Now, here you use that phone calls variation, which is very important. I teach this to the revision students. FONCLS. So, phone calls, it's like this. Phone calls variation. So, FONCLS. එතකොට FONCL වලට පස්සේ තමයි S වෙන්නේ, right? So, Cl is more electronegative than sulfur. So, this statement is wrong, right? So this is a perfect application of that phone calls variation. It's a direct MCQ. The boiling points of no, there are some more things you have to remember. Carbon is larger than hydrogen and phosphorus is larger than hydrogen. මේ දෙකත් පොඩ්ඩක් මතක තියාගන්න. Like back of your mind, have this in your mind, right? So the next one, increasing order of electronegativity of the carbon atom means CH4, CH3, CH3Cl, H2CO, HCN, and NCO minus. Right. Electronegativity of carbon atom. So we have to check the central atom actually. So this is CH4. This is COH2. Meanwhile, this is CH3Cl. And then this is HCN. And this is NCO. Right. So yeah, you go. So these are the structures of the compounds. So sp hybridized compounds have the largest electronegativity. First of all, you look at the Pauling scale. So central carbon atom or nitrogen atom or oxygen atom, whatever the atom you check. After you check the atom, then you go for the hybridization. If the atoms are same, for example, here you have to consider carbon everywhere. So then we look at the hybridization. So hybridization is SP for this one. This one is SP again. This one is SP3. This one is SP3. And this one is SP2. So here you can see that HCN and NCO minus have a larger electronegativity. Out of them, who has a large electronegativity? After you look at the hybridization, then you look at the charge. Actually, the charge is zero. The charge is zero. Right? After that, only you look at oxidation number. So oxidation number, when you compare here, minus, plus, plus, and plus. So that's going to be plus 2 for this carbon. This carbon, 1, 2, 3, and 4. That's plus 4. So plus 4 oxidation number has a larger electronegativity. So actually CNO minus has the largest electronegativity. Then comes HCN. So this one can be an answer, this one can be an answer, this one can be an answer. But this one, then this one can't be an answer. So out of these three, one of them should be the answer. Right. Then we look at the next compound. sp2 hybridized carbon should we have a large electronegativity after that. H2CO. So this can't be an answer because CH3Cl they are put on in front. So after that we have to check CH3Cl and CH4. So here you have to also check on the electronegativity by the oxidation number. So here it's going to be minus 4. Here it's going to be 1, 2, 3, minus 2 because chlorine is more electronegative than carbon. Therefore, the oxidation number given for the carbon atom will be minus 2. So actually CH3Cl has a larger electronegativity than CH4. So the answer will be answer number 3. Answer will be answer number 3. All right. I'll do the calculation questions at the end. Okay. Fifth question. Two identical closed rigid containers at standard temperature and pressure contain 1 mole of H2 and 2 moles of oxygen. Okay, so they are at standard temperature and pressure. Two identical closed rigid containers, volume is constant, right? Temperature is constant and pressure is also constant. Don't forget that P, V, and T are constant, right? 1 mole of hydrogen and 2 moles of oxygen. 1 mole of hydrogen and 2 moles of oxygen. So their mole value is different. So there is a system of hydrogen with 2 moles of O2, and there's another one with 1 mole of H2. Which of the following is true of the above two systems? Both H2 and O2 have same average kinetic energy. So average kinetic energy is the mean kinetic energy actually. Both are same. Kinetic energy is equal to 3RT over 2, which does not depend on the molar mass. So only depends on the temperature. They are told that the temperature is same. So of course average kinetic energy should be same. So that statement is correct. Both H2 gas and O2 gas have the same average speed. Now that is wrong because mean square speed is 3RT over M because it depends on the molar mass. When the compound changes, the mean square speed changes. So that statement is wrong. Both H2 gas and O2 gas have the same mass. Both H2 gas and O2 gas have the same mass. That also can't be happening, right? That also can't be happening because the number of moles are different and also the molar mass is different. So number of moles multiplied by molar mass, you get the mass. So that statement is wrong. Both H2 gas and O2 gas have the same density. If the masses are different, then of course density is different. So mass over volume is density, and although the volume is equal, the masses are different. So that statement is also wrong. Fifth one, both H2 gas and O2 gas have the same effusion rate. What is this effusion rate? Effusion rate is the how fast the molecule can move. මහත වැඩි දුවන්න බැරි වෙනස ඉන්නේ නැතින්, like when you become fatter and fatter you can't run faster, right? So that kind of thing only going on. So effusion rate of actually H2 is larger than O2, right? H2 is larger than O2. They don't have the same effusion rate. So you have the answer number one there. That's question number 5. Then these two are also calculations. Then you have the eighth one. Now this is kinetics. This is kinetics. Okay, I'll tell the answer, but these things I haven't told you. I thought actually this is from Unit 4. So this is a 2022 A-level paper. For a given chemical reaction, which of the following is or are affected by the temperature? Collision frequency of reactant molecules. Yes. When temperature increases, collision frequency increases because they are going to move faster. So fast moving faster means faster collision frequency. Kinetic energy of colliding molecules. That is correct. Standard enthalpy change. Enthalpy will not change. And activation energy of the reaction. Activation energy also will not change because of temperature, right? Nothing can change the activation energy actually. Syllabus catalyst you might now may argue with me. If you add a catalyst, activation energy can decrease, but in the syllabus you are taking, it's creating a new pathway. Activation energy cannot be reduced by anything. Answer is answer number 1. Which of the following are true, right? They're asking yes. Okay, answer is answer number 1 there. So which of the following statements is correct regarding to nitric acid, HNO3 and its salt? Both dilute and concentrated HNO3 acts as oxidizing agent. That reaction is correct. That statement is correct. We have learned these reactions under HNO3 in the revision class. I won't go much detail into it. We have studied all the reactions which come under them. Part B, thermal decomposition of ammonium nitrate gives N2O and water. So ammonium nitrate decomposition, ammonium nitrite decomposition, and ammonium dichromate decomposition. So these decompositions, I told you, they are very important. They do not produce ammonia. These are the only 3 salts which do not produce ammonia. So ammonium nitrate will give N2O and H2O. Meanwhile, this will give N2 and H2O. Meanwhile, this will give Cr2O3 plus N2 plus H2O. So I had to balance these reactions. I told you how to balance them easily in the class. So I won't go much detail into it. Right. Thermal decomposition of ammonium nitrate will give N2 and water. That's correct. Then part C, NO bonds of HNO3 are equal in length. Right. HNO3 molecule will look something like this. So this is the Lewis structure. If we draw another resonance structure for this, So this is the other stable resonance structure. So actually there are only two stable resonance structures for this molecule. The other resonance structure is unstable actually. So oxygen gets a positive charge there. So that one is not formed. Although you can draw it on the paper, it's not formed in real life. So this is the other resonance structure. So we don't consider this, only this and this. So when you consider these two, we can draw the resonance hybrid. The resonance hybrid will look something like this. You can put a dotted line there. Now these dotted lines represent the bonds are equal there, which gives a charge of zero, right? There is no charge here for the molecule. The charges cancel off. Or else you can draw it like this. Put a plus at the center and put a minus half to this oxygen atom. That's also working. So they are telling NO bonds of HNO3 are all equally linked. Not all actually. This bond is different to these two bonds, right? The oxygen nitrogen bond on the left hand side, this bond is actually different to the other two bonds because this bond order is 1.5, right? These two bonds are 1.5 bond order, but this bond is just one because there's only one sigma bond and there is no chance of making a pi bond. So there you go. NO bond lengths are all equally linked. That's wrong. Carbon does not react with concentrated HNO3 when heated. It reacts actually. Carbon reaction we learned in the class. Carbon with HNO3, it will form carbon dioxide. We learned this in the class. So answer is answer number one. 10th question. When H2S gas reacts with acidic solution of K2Cr2O7, elemental sulfur is formed. Yes, that's correct. H2S will form sulfur, which will give a yellow color turbidity. This reaction is very important because Cr2O7 2 minus, it will go to Cr3 plus, which will give a green color, as well as H2S will go to sulfur and it will give a yellow color precipitation. So it's like, yellow green color turbid solution only you're getting, right? Yellow and mixed with green color turbid solution you're getting. So that's correct. H2S gas can act as a reducing agent in acidic medium. Yes. H2S gas can act as a reducing agent in acidic medium. So this explains the first statement or not. So Cr2O7 undergoes reduction. So H2S can act as a reducing agent. So yeah, I'll go for answer number one there. Right. If they talk about oxidizing agent, then the answer could be answer number two, right? Then the answer could be answer number two. Right. So that is that. I'll go with the calculation questions now. I take a screenshot and go for the whiteboard. Right. So this question 0.4314 grams of pure iron oxalate FeC2O4. So this reaction is very important because there are two ions. Both of them will undergo reaction. Oxalate as well as Fe2 plus both undergo reaction. Was dissolved in excess dilute H2SO4, so the reaction medium is acidic. The entire solution was titrated with KMnO4. The burette reading at the end point was of the reading is okay. Now this reaction you might think this is very easy, and you might just consider Fe2 plus and Mn2 plus MnO4 2 minus reaction and then get an answer. If you get like that, you're wrong actually. Here not only Fe2 plus but oxalate is undergoing reaction. With an oxalate with reactant, please be careful regarding that. Oxalate will go to carbon dioxide, MnO4 minus will go to Mn2 plus, and meanwhile, finally, Fe2 plus will go to Fe3 plus. So there you go. Here to here, it will be plus 1. Here to here plus 7 actually, here plus 2, then it's going to be plus 5, plus 1, sorry, minus 5. And then from here to here, this is 2 carbon dioxide, which will give you plus 8, and this will give you plus 6, which will be plus 2. So now what you do, I taught you this in the class, you're going to add these two together, you will get plus 3. 3 actually, 2 not gonna right? 3. So now you find the least common multiple by multiplying these two numbers. 5 into 3, 3 into 5, right? 5 into 3 and 3 into 5. 3 into 5 means it will be 10 carbon dioxide, 5 oxalate, 5 Fe2 plus, then 3 permanganate and 3 Mn2 plus. Now the rest of the balancing you can do it. Actually, you don't need this for the MCQ. Adding H plus and what do you call me water. So I'm going to continue to the question from this point. Right. They have given the concentration and the volume. Sorry, they haven't given the volume. They have given the number of the mass of 0. mass of 0.4314, that's the mass of iron oxalate. So I'm going to find the number of moles of FeC2O4. Number of moles of FeC2O4 will be 0.4314 grams divided by molar mass, 143.5, right? Yes, 143.8 grams per mole. So if we divide this and take exactly 0.4314 divided by 143.8. That's 3 10 to the power minus 3. So 3 10 to the power minus 3 moles will be the answer of for the number of moles of FeC2O4. If number of moles of FeC2O4 is this much, number of moles of Fe2 plus will be same value, right? Right. Then we can go for the stoichiometric ratio Fe2 plus to MnO4 minus. So number of moles of MnO4 minus will be 3 into 10 to the power minus 3 multiplied by 3 over 5. Right. So 9 over 5 into 10 to the power minus 3. That's going to be 1.8 into 10 to the power minus 3 moles. Now you have calculated the number of moles of MnO4 minus. After you calculate the number of moles of MnO4 minus, you can go for the volume of it by dividing with the concentration volume of MnO4 minus consumed. So 1.8 10 to the power minus 3 moles divided by the concentration, which is going to be, what is the concentration? 0.06. 0.06 mole per cubic decimeter. So moles and moles cancel. 1.8 divided by 0.06, that is 30 10 to the power minus 3. And per cubic decimeters comes on top and it will be cubic decimeters. So the answer is 30 cubic centimeters. So there you go. Answer is answer number 3. Answer is answer number 3. Next question, which of the following statements incorrect with regard to the reaction given below under the standard conditions? For 1 mole of reaction, 483.7 kilojoules of heat energy is released. Okay, if 1 mole of for 1 mole of reaction, yes, for 1 mole of reaction, actually 483.7 kilojoules per mole is released. That statement is correct. Second one, for 2 moles of hydrogen consumed, yeah, that is correct. Now here 2 moles, because the stoichiometry is 2, so you need 2 moles of H2 and 1 mole of oxygen to release minus 483.7. So that is absolutely correct. You can go with that. Then third one, for 2 moles of H2O gas produced, for 2 moles of H2O gas produced 480. Oh yes, that is also correct, right? Because 2 molecules of H2O is formed. For the reaction of 4H2 and 2 oxygen, 967.4. So that's actually twice neither. Heat energy is evolved. Yes, actually, you are going to multiply everything by 2. That statement is correct. For 1 mole of oxygen consumed, no, that is wrong. That's directly wrong. Like very easy question. 1 mole of oxygen consumed, this much amount of energy is by stoichiometry is 1. If stoichiometry is 1, 1 mole is reacted, and this will be the amount of energy released, because that is how it is, right? So the fifth one is the answer. It's not a calculation actually. So yeah, here answer is 3 and answer is number 5. Okay, only 2 questions remaining. I'll do this 2 also. I had done this in the revision class actually. These both questions comes under limiting reagent part. Right. Sixth question.
Oh my god! All this time I was putting on my mic to the ear, and then I was speaking with the laptop microphone. I couldn't switch it to the microphone which is in my ear right now. So sorry about that. I hope you have heard me clearly. Right. The sixth question. A mixture containing 3 moles of magnesium metal and unknown amount of lithium metal was completely reacted with excess nitrogen. So lithium plus nitrogen reaction, lithium nitride is formed. So actually it's 3 and it's 6 here and here 2. So this is the balanced chemical equation. Magnesium plus nitrogen, magnesium nitride, Mg3N2. So here it will be 3, right? They are saying completely reacted. Unknown amount of lithium metal was reacted with complete. Okay, 3 moles of magnesium metal. So magnesium amount we know 3 moles, but this one we don't know. I'm going to put X there, right? Number of moles of lithium reacted. I'm going to put X there. So when the product mixture resulting from this reaction was completely reacted with excess water. So both of these are reacted. Don't forget, both of these are reacted. They have given the reactions actually lithium nitride and water, magnesium nitride and water. They don't have to give this actually because they are learning this in inorganic. Nitride reacted with water. Um, yeah, unknown amount of lithium metal was reacted completely with excess nitrogen. When the product mixture resulting from this was reacted excess water, 44.2 grams of ammonia gas was produced. Okay, let's see number of moles of lithium nitride. Number of moles of lithium nitride will be, now this is X, right? If this is X, number of moles of lithium nitride will be 3 times less, right? Because 6 is to 2 is the ratio. That means 3 is to 1. That's going to be X over 3. The number of moles of magnesium nitride, Mg3N2, will be again 3 is to 1. So that's going to be 1 mole, right? Now look at these two reactions. So 1 mole of magnesium nitride and then X over 3 moles of lithium nitride is going to react. So the number of moles of ammonia from magnesium nitride. So magnesium nitride will produce some amount of what you call me ammonia, right? Magnesium nitride will form some amount of ammonia. From that, Mg3N2, number of moles of ammonia from Mg3N2 will be 1 into, because magnesium nitride ratio is 1 is to 2. So that is 2. So 2 moles. 2 moles of ammonia is produced. Then number of moles of ammonia from lithium nitride, Li3N, will be 1 is to 1 ratio again. So it's going to be X over 3. Right? It's going to be X over 3. So total ammonia will be 2 plus X over 3. So also I can get, they have given the mass actually, total ammonia mass, 44.2 grams of ammonia they have given. So we can calculate the number of moles of ammonia, 44.2 grams divided by 17 grams per mole, right? 44.2 divided by 17 grams per mole, 2.6 grams. So now we can equate this one and this one because they are equal. 2.6, not grams, actually moles. Right? 2.6 is equal to 2 plus x over 3. Right? Then 0.6 is equal to x over 3. And then x is going to be 1.8 moles. If you know the moles of lithium, now x is the moles of lithium. If you know the moles of lithium, we can multiply by the molar mass. Mass of lithium will be 1.8 moles. Will be 1.8 moles multiplied by 7 grams per mole. Right. So 7 into 8, 56, 5. So now 7 and 56, right? Yes, 56, 1, 7, 5, 12, 1, 12.6 grams. 12.8 then. 12.6, right? This is the answer is. I was looking at this. Okay. The answer is answer number 3 for the 6th question. 7th question, let's see about that. That's also a limiting reagent based question. I'll go for that one. Seventh question. Ammonia can be synthesized at high temperatures as shown in the balanced chemical equation. So maximum amount of ammonia grams that can be synthesized from 45 grams of NO and 12 grams of H2. So 12 grams of H2 and then 45 grams of NO is reacted. So we can say number of moles of H2 will be equal to 12 grams divided by 2 grams per mole. That's the number of moles of H2, which will be 6 moles. Then number of moles of NO will be 45 grams divided by molar mass of NO 16, 20, 30. 30 grams per mole. 15 times 2, 15 times 3, that is 1.5 moles. Right. So now what we do, we find the limiting reagent. Who is the limiting reagent? So they haven't balanced the reaction, right? Yeah, they haven't balanced the reaction. This is an unbalanced chemical reaction, so we have to balance it out. H2 goes to ammonia plus H2O. So here if we put, now oxygen is okay, nitrogen is also okay. Hydrogen is the problem. There are 5 hydrogens on the right hand side. So if I put 5 here, 2 here, 2 here, and 2 here, it's going to get balanced. 5 into 2, 10 hydrogen, 3 into 3, 9. No. No. 3, 4, 5, right? H2O, ne? Sorry, H2O. Nitrogen is 1, oxygen is 1. Yeah, I think it's gonna be 5 over 2. If it is 5 over 2 here, if we multiply everything by 2, it's gonna be 5, 2, 2, and 2. 3 into 2, 6. Yeah, 2 into 2, 4, that's 10. Yeah, that's the balanced chemical equation. Right. Then we can find the limiting reagent. So limiting reagent here would be hydrogen, right? There are 6 moles of hydrogen and 1.5 moles of NO, but the stoichiometry here is 5. So 6 divided by 5 is going to be 6 divided by 5 is going to be 1.2. 1.2, right? 1.2. And 1.5 divided by 2. No. Then the limiting reagent will be 0.75, right? So that's going to be NO. NO is the limiting reagent. So that means everything of NO will react. Everything of NO will react. So everything of NO will react means we can track the ammonia amount by using NO. Number of moles of ammonia is equal to the same value, actually stoichiometry is same. So that's going to be 0.75 moles. Right? 0.75 moles. So mass of ammonia 0.75 moles multiplied by 17 grams per mole, right? 0.75 multiplied by 17, that is 12.75 grams. Which is closer to the third one. We are not getting an exact answer there. Maybe some calculation issue somewhere. Balance the reaction correct, right? Yeah, 1.5 will be the answer there for the number of moles of NO. Then we multiply by the molar mass of ammonia. It's not 0.75, right? It's not 0.75. Number of moles of ammonia formed will be same amount, 1.5 moles. So 1.5 multiplied by 17. Right? 1.5 multiplied by 17, that's going to be 25.5. Yes, that's the answer. Sorry, my bad. I messed up with the amount. So 25.5 is the answer. So answer number 4. So with that, the missile paper number 2 discussion is done. Hope you learned something new with these 10 questions. So our next one will start. I'll send the next PDF today so you can complete that too. Yeah, thank you for watching. See you again in the next video.